Basically, Azure DevTest Labs helps you to provision lab environments in the cloud, in the Azure cloud. If you have lab environments on-prem, you in general have a pretty massive infrastructure you have to buy to maintain just to do your dev and test environments. And with the aid of cloud or with the aid of Azure, you can leverage the cloud or you can leverage the flexibility of the cloud to maybe save some money, because I'll try with the mic, maybe.
Is it on?
Yeah. Okay. You have, in general, you have a pretty massive amount of unused capacity on your infrastructure on premise, because development environments and test environments are most of the times they're maybe not used, because you are going to test software just in maybe every 2 weeks. Maybe you have some lab environments or educational environments which you use for trainings every few days or something. And with the cloud you may be able to save some money, because you can spin up your VMs, you can spin up your environments just as you need them, and you can shut down if you don't need them. So there are different use cases for Azure DevTest Labs. Basically, there's a developer use case where devs spin up their VMs, their development environments with all the necessary software in the cloud and start to work. There is a training and educational scenario where you maybe have some attendees in a training which all need a VM where they can do their labs, for example. Means you can spin up 10, 20 VMs in the cloud, give access to your attendees, and then can use these VMs in the training. Pretty much the same scenario goes for trial and demo environments. If you have customers which want to which you want to demo your software, for example, you can use DevTest Labs as well. And as well for test environments, we'll go into detail for this case, where you have maybe a software which you built, you have your release pipeline, you can release the software in a DevTest Lab environment, you can give access to your testers, and they can test the software, and afterwards you can release it to production, for example.
Thank you very much. So, Stefan is still in the old mode, so it's not Azure DevTest Lab, it's called Azure Lab Services. It changed, as he mentioned before, 2 weeks ago. So, to get the context right, you have now the umbrella, it will be called Azure Lab Services, and then you have one pillar will be Azure DevTest Labs, and then you have the so-called managed labs. Currently it is in preview. It's called Classroom Labs, where you can provide in a very simple way VMs to your, for example, for your classroom training, or if you have company trainings and so on. So what is the difference between those two, DevTest Labs and Lab Service? I mean, you haven't heard of it, so maybe you don't know exactly what the difference is. Basically, the managed labs, they are fully managed by Microsoft. As you will see in the demo there, you cannot change too many things. On the opposite, there is DevTest Lab, where Microsoft still does a lot of work in the background, but you are more flexible to manage things. One thing you cannot manage is automation using ARM in the managed labs, and the rest, subscription and resources and scale out, is everything managed by Microsoft. In the managed labs, at DevTest Lab, you have some chances to influence all this stuff. Okay, so what's going on behind the scenes? It's in both ways about the same, what's going on. You create a lab, then a resource group will be provisioned, storage account will be provisioned, virtual network will be provisioned for you, and also Azure Key Vault to securely store your credentials. Everything will be provisioned in the resource group, and from there you can then provision your virtual machines. Everything clear so far? Okay.
What's the bit advantage of just doing it yourself? Just take like 2 minutes.
Sorry, I did not get the
It takes
question.
like 2 minutes to do that yourself. So what is the big advantage of doing it?
We will show you.
Okay.
Okay, then you sit there, your classmates will sit there consuming all the virtual machines or the labs they have. The administrator will control access, control images, control VM sizes, control number of VMs, and also auto start, shutdown, and many more. And as Stefan will show you, there is also some automation you can use, CI/CD pipelines, which will maybe make it easier your life. And of course the networks. So I will give you now an overview, a demo. Okay, can you hear me without microphone? Okay. Yeah, it's what was it? Okay. Yes.
We can hear, we can't see.
anything.
You cannot see it? Ui, that's bad.
Ah, so we can't see something, but now probably what you want to show.
Yeah, I have this one.
On it.
Da. Okay, fixed. So first, the use case Azure DevTest Lab. You remember the lab where you can do some more changes. I'm not going to provision it in real time because we don't have enough time. But basically, you just say, okay, my lab name. In my case, it's demo 01. You provide the name and the subscription and all the stuff you know from Azure. And then you get the lab bucket, basically. And then if you go for the resource group, you will see that all the resources are being created for you. Everything there. I did just create a lab, and that's been created in the background. So I already have my test lab for testing some stuff I created, and I have also some virtual machines running in there. The most interesting parts I'm showing here. We don't have enough time to go through each of these settings, but the most interesting one. So first, you will see how much consumption it will use, everything you're running in the lab. You can configure it to show the lines when you should receive an alert if it exceeds, for example, $300, and you just want to spend $200, you get an alert in advance. If it's used 25%, 75% of the usage. You have an exact splitting by the resources, which resources uses most of the cost of your lab. So as a classroom teacher, it's maybe good to know what's going on. Then now there are advantages. Let's imagine you have classmates, and they always want to have the biggest machine, the greatest machine, the fastest machine, whatever, and you don't want to allow them to give them the most powerful machines. So you just restrict them and say, okay, you can just use those certain virtual machines. You just enable it, and then you are able to select all the sizes you would like to provide. Here the cores, and here the memory. Then the next, you can restrict how many virtual machine a user can claim. So just one or two, and if they are able to use, the SSDs. They also cost a lot of money. Maybe they should not be able to use the premium SSD disks. Then also you can restrict how many machines there should be provisioned per lab. And for example, the very cool feature to save here some money is also, we mentioned in the beginning, you can, when your classroom starts, then you can use a schedule, so the virtual machine are always started up, and you can start your training at any point in time here. And also in the evening, you don't forget to shut down all virtual machines. You can use auto shutdown, and all the virtual machines are shut down.
You can also use, for example, logic apps to trigger an email notification to the owner of a VM to notify him that his VM is going to shut down in 15 minutes or so. And within the email, you can allow him to extend the shutdown so that the VM is not shut down in the next 15 minutes, but in the next hour instead, for example.
Exactly. And you can not only restrict the size of the virtual machine, of course, you can also the marketplace image, you can restrict. So it's only for example, for Windows Server, Linux, SQL Server, or whatever training you have, so they don't deploy anything else than that. It's the same way as you do it for the sizing. You just select yes up here, and then you select whatever you want to provide for this classroom training. And of course you can upload your custom images if you want. And I mean that's basic stuff here, but Stefan will show you a more extended way of it. So there is something called Artifact, where you can get some configuration from GitHub. And there is a other thing called Formulas, where you have a bucket where you configure the size, the image, and also the artifacts from GitHub. So the trainees only select that formula and get everything provided in the background. Stefan will show it to you in a demo. So that's a basic overview of DevTest Lab. There is much more.
Maybe just to come back to your question, all these restrictions you see here, VM sizes and all this stuff, you can do that in normal Azure environment by using policies, for example, but it gets more and more complicated.
Yeah, this is a lot easier. I get the point. Yeah.
Okay, now we are switching to the managed lab side. As for the DevTest Lab, you need to create a bucket that's here called Lab Accounts. I created two labs, Test Lab and Java Lab. As soon as they are provisioned, you can log in labsazure.com with your account, and then you're the trainer, and you can start creating a new virtual machine from any template. As I did here, I created a virtual machine for Windows Server 2016. Currently there is only SQL Server and the Linux version available, and it's basically a base image. After this is provisioned, you log into this image, make all your customization you want to provide to your trainees. When you're finished, you shut down the virtual machine, and then you can publish this image here. Go to publish, and then it's publicly available. Meaning, you can send the link for this lab to your users. Just this link here. And what the user will see is just like this. He gets this big button and access to this virtual machine. He can then start it. It will be started, and he can remotely connect to that virtual machine. What happened in the background when you start it? The Mensch Lab will sysprep the image with all your installed software. The end user gets this image starts up and does all the configuration, and also provision in the background the network. So if you, for example, start a second machine, they are in the same network and they can talk to each other within the same lab. So you only need to provision or provide the image, and the rest is done. You don't have to configure network, you don't have to configure resource group or subscription or anything. It's just create the lab account in the portal, and then you configure image and deploy it to your end users. And I think it's a great idea for classroom trainings, where you have some, or for demo purposes. It's very, very easy. It's in previews. There are still some limitations and so on, but you also can see here there will be a schedule to shut down the virtual machines, and there are only 5 users who can use now this image. Okay?
Okay, now switching over a little bit to the dev or test environment part. I tried to do a sample where you have an application which you want to deploy to a test environment and give access to some testers to be able to test the software, which maybe had some changes recently, before releasing it to production. So I created a simple PHP MySQL app where you can search for service manager, build numbers and stuff. And this application, it's a small web app. Code is hosted on GitHub, some PHP files. We have some CSV files which contain some basic data which is imported to MySQL database. And to run the app we have, or we need a server, obviously, which runs Linux, and we also need MariaDB, PHP installed, we need Apache server, for example, to run the app. Before we can run the app, we need to download PHP files, we need to import CSV files into the database and all this stuff. So it's basically a pretty big puzzle for such a small application. We have to solve every time we want to deploy the application to a new server when we did some changes to the app source code. What helps you, or what helps us with this problem, are artifacts. If you have virtual machines in Azure DevTest Labs, you can add artifacts to these machines, either on runtime. So if the machines are running already, you can add artifacts, or you can also add artifacts when building the machine. What you can do is you can have your artifact hosted either on GitHub or Visual Studio Team Services, and if you are configuring your machine, you can add these artifacts to be installed when the machine is started, or if the machine is built in Azure. In addition to artifacts, we also have formulas. Imagine you may have, in this sample we have PHP, which we have to install. We have Apache web server. We need to get the source code from GitHub, and we need to somehow install the application, our custom application. So what we need to do is define kind of a sequence, what is performed on this VM until the application is installed. For example, at first we need to install PHP, afterwards we need to install Apache web server, we need to install MySQL or MariaDB, we need to get the source code, and so on and so on. For that, we can use formulas. Means we take a base image, which is, for example, Ubuntu server image from Microsoft, which is available in the Azure Marketplace. We are then applying multiple artifacts. For example, we are applying an artifact which installs all the base software requirements like Apache and PHP. We afterwards apply another artifact which gets the source code from GitHub and copies the files from somewhere home directory to the Apache web service directory, and so on. Basically, formulas are a pretty cool thing to build your machines in Azure DevTest Labs, because you can really have like templates which you can give your users to dynamically build a virtual machine. You can also use this to build, for example, developer machines, where you have a base image, which may be Windows 10, and with artifacts you can then install, for example, Visual Studio. You can check out source code from your repository. You can install Notepad or Chrome and all the stuff you need, for example, to develop your web application. And you always get the latest versions of your products. You don't have to maintain a golden image, which your users then use. Instead, you can use formulas. Formulas have one downside. It takes longer until VMs are created with the formulas if you use them instead of the images. But I think there are much more advantages compared to using images in this case. When using formulas and also when using custom images, you can integrate your VM creation into a release pipeline. For example, you can use Visual Studio Online to build your VM or to initiate a release pipeline when you commit some new code to your application. In the demo, I will show you I will commit a change to my sample application, commit to GitHub. This will trigger the release pipeline in Visual Studio Online, which then creates a new VM. With the new version of the application, it creates an image, it deletes the old VM, and you can then create, for example, new VMs which have an expiry date of 30 days or something. For integration into Visual Studio Online, you can use tasks. There are 3 different tasks available, like delete VM, create VM, and create custom image, and we will all see them in the demo afterwards. So, yeah, that's really kind of the cool thing about this release pipeline thing. You can combine all the good stuff from Azure DevTest Labs, like you can combine custom images with formulas, with ARM templates, to have a really cool release pipeline to release new versions, for example, of your software, or to easily release new testing images with each release of your software, without having to do this puzzle over and over again every time you do a change to your custom application. Well then, let's switch to the demo.
Yes, okay, he mentioned artifact, I mentioned artifacts, but what are artifacts technically? It's basically a JSON file with some configuration in it stored in GitHub, right? And then you in DevTest Lab, you just use the repo pointing to that JSON configuration file, which gets applied to the image.
That's basically it. Yeah, with artifacts you have, besides the JSON configuration, you also have a script which does all the hard work. But I will show you an example of an artifact in a minute. That's basically just to show you that's the demo app I have. It has some basic functionality, but we won't dive into this one. What I want to show you is my GitHub repository. which contains the app files, the necessary files, like I have an index PHP. I have also the TXT files which contain the data, which is afterwards imported into MySQL. And what I also have hosted in my GitHub repository are templates and artifacts. And I have 3 different custom artifacts in my GitHub, like install MariaDB. That's a custom artifact which just installs MariaDB and sets a root user password for the database. That one is the most interesting one. That's the artifact which actually installs my custom application. So what you have is a artifact file. That's basically the JSON, which defines how this artifact is named, and it has a description. It also has a target OS type, so you can create artifacts for Linux as well as for Windows, and only the ones which are specified for a certain operating system are shown in the Azure portal, for example. But we have to specify as well is the path to a shell script in this case. This can be a PowerShell script as well, which does contain the logic or does the hard work afterwards of installing the application. If we take a look at the shell script in this case, we can see that this is basically the part where I'm installing my app. So I'm cloning my Git repo. I'm replacing some default passwords. I'm creating the database, and I'm copying the source file which I got from GitHub, and copying them to my Apache web server directory. So building artifacts is pretty easy. If you have some custom application, create your own artifact. It's really not that difficult. And besides your custom artifacts, you also have many artifacts which are already present by default. Microsoft has its own GitHub repository where they create their own artifacts and publish them to all Azure DevTest Labs users. If you configure your repositories in Azure DevTest Labs, you will have a public repo by default. That's the repository of Microsoft. And if we take a look at what artifacts are available there, you can see that there are some pretty cool things which you can use just out of the box. You can also contribute to this public repo by Microsoft. If you have your own artifact developed and you want to provide this to all Azure DevTest Labs users, you can simply create a pull request. Microsoft will approve it if it's okay for them, and your artifact will appear in the default repository. So as you can see, for example, the apt-get artifact is pretty useful if you want to install some software on a Linux box. You can use apt-get artifact just to install pretty much everything which is available in a repository of a given distribution. And there are many more. Same goes for Windows, of course. Okay. And besides my artifacts, I also created some templates. These are basically ARM templates, which are used for creating the VMs afterwards when we create the VMs from the release pipeline. That's an ARM template which describes what packages, for example, in this case, are going to installed by using this apt-get artifact. Also, I specify a MariaDB password. That's not for demo purposes, that's okay to have it like in GitHub and not encrypted and all this. I also have the resources. That's basically the server image I'm using. I'm using an Ubuntu image to provision this VM, and these are the artifacts which are applied to this image. First of all, we have the apt-get artifact. We have the artifact which installs my application afterwards. And as you can see, these are from a private repo, in this case, because that's my own custom repository I configured in DevTest Labs. On contrary, the apt-get artifact is from public Microsoft repository. Well, if we take a look at our release pipeline, we have our artifact, or we have our source code in GitHub, and we have a trigger which starts our release every time I do a commit in GitHub. And if we take a look at our pipeline, there we have different tasks which are used to create our test environment or to update our test environment. First of all, we are creating a base VM with the template I've shown you before. So an Ubuntu image is taken, all the artifacts are applied. Means after this VM is created, we have a fully functioning VM where you can start up your application. After that, I'll create an image from this VM. That's the second step here. And when I have this image, I'm going to delete the initially created VM because I don't want to, in a productive environment, you don't want to have VMs which are not used. I think the image is sufficient. It's just sufficient to have an image for each software release you have. From this image, you can then easily create VMs. And as we've seen before in the slides, if you have an image, creation of a VM based on this image takes just seconds. So you can provide this image to your users. They can come, they can log in to Azure Portal, Azure DevTest Labs, create a VM from an image from a specific software version, start up the VM, and they are ready to test, for example. In this case, just for demo purposes, I created new VMs based on this image, which have an expiration date. That's also a pretty cool feature you can set. You can set an expiration date for each VM in Azure DevTest Labs, and after the VM expires, it gets deleted automatically. Okay, and yeah, that's basically a running pipeline. Now I started that just before the session, and if we take a look at our lab, you can see that we have VMs available. There's still a VM. There's still a VM being created where artifacts are applied. You can see from previous runs of the release pipeline that we have 2 VMs each available based on a certain software version. So I can create, or I can just simply claim this VM and spin it up and go to work. But we have as well, if you take a look at our custom images, we have as well images for each release of our software. So if you want to go back to a certain point in time and spin up a VM, maybe a customer comes to you, has a problem with a certain version of the software, you can simply spin up a VM with the version of the software, try to reproduce his issues. Well, I think I'll switch back to presentation for the last few minutes. Yeah, basically, I hope you got an overview what Azure DevTest Labs can do for you. It's, as the title of the session says, it's kind of a hidden gem in Azure. There are not many people which know about Azure DevTest Labs. I think it's a very good solution to create your test environments, as well as with the new lab services to have your educational or training environments ready within some minutes or maybe even seconds. You don't have to worry about Azure resources. You don't need much know-how in Azure. You don't necessarily have to be an expert in VNets, for example, and key stores and all this stuff. Azure DevTest Labs does that for you. It's free to use. Free to use in terms of you pay for the resources, of course, which you provision, the VMs and so on, but you don't pay for the lab services, so no base fee for labs. And you have you can control your environment in an easy way. So as you've seen in the demo from Stefan, just configure your dev test environment, how many VMs can be started, what images can be used. It's really easy to configure compared to, for example, using policies when you do it all yourself in Azure Resource Groups. And you can integrate it in your existing toolchain if you are using a release pipeline or something. Integrate it. I think it's pretty cool. Try it out and hopefully have fun.
Yeah, and what you should maybe keep an eye on is all the managed labs. I mean, the classroom labs, that's just the preview version now. I could imagine, I don't know, but I could imagine that there will be something more for developer where you have maybe more options or something like that. Or use it for your own testing. I mean, you have immediately deployed those images. That's absolutely a time saver. That's how I use the stuff.
Mm-hmm.
Okay. Any questions so far? No? Everything clear?
You can, for example, also integrate, if you have an enterprise environment in Azure where you have your virtual machines, you maybe have your VPN connected to a virtual network in Azure. You can also configure Azure DevTest Lab to use this existing virtual network, for example, so you can connect from on-prem through VPN to your DevTest Labs VMs. It is pretty flexible, actually, also when it comes to integration in existing enterprise environments. Yeah, that's it from our side. Thanks.